You have a stream of numbers and you need the max sum of every group of say 3. Sure, you could use brute force, check every group one by one, adding from scratch each time, which is slow. But sliding window is fast. Whether it's an array, a string, or real-time sensor data, sliding windows let you scan continuously without redoing work. In the next few minutes, you'll see exactly how and why it works. And here is our window. First, we define the window size, also called K. In this case, K is 3, meaning we will be looking at groups of 3 numbers. Now we calculate the window sum. Start with the first window, 2, 1, 5. Add them up. 2 plus 1 plus 5 is 8. This 8 becomes our max sum, the largest total we have seen so far. We will keep updating the window sum, since it tracks the total of the current window as we slide forward. Slide one step to the right. Drop 2, add 1. 8 minus 2 plus 1 is 7. We compare it with the max so far, 8, and keep the higher one. Notice 1 subtraction, 1 addition. That's it. Slide again. Drop 1, add 3. 7 minus 1 plus 3 is 9. New max found. If we had recalculated 5 plus 1 plus 3 equals 9, same result, yes, but slower. Over large arrays, this efficiency adds up. Drop 5, add 2, 9 minus 5 plus 2 is 6. It's lower than our current max, so we don't update. Again, no full sum needed, just a quick update. Drop 1, add 4, 6 minus 1 plus 4 is 9. We match our current max again, fast and clean. And final slide. Drop 3, add 6, 9 minus 3 plus 6 is 12. No max is 12. That's the highest sum across all windows. Sliding window eliminates redundancy. No need to recalculate from scratch. Just update in constant time. Subtract what leaves, add what enters. But it's more than a trick for sums. It's a powerful framework for solving any problem that involves efficient step-by-step processing of continuous data. Use it wherever updates can be reused instead of repeated.